Very good morning, everybody. It's great to see some of you guys back here, and it's great to see some new faces as well. Thank you guys all so much for coming. How is everybody doing this morning? Okay, fantastic, fantastic. Are you guys all having an absolutely fantastic time here? Wonderful, brilliant. That's great. Oh, did anybody else get confused by shore time being an hour different to ship time? That fully confused me. I feel I should let you guys know, if you are here for the bingo, you're an hour early, okay? So that's coming up, but hopefully you can stick around. So I did get a bit confused by that. How many people came along to our stargazing evening a couple of nights ago? Okay, a few guys. I can see why if you took a pass, because if you looked out the window, it did look like it was going to be much more a cloud-gazing evening, right? But we did actually see a whole constellation, which I was really quite relieved at. I thought, we can see that. And we saw a couple of satellites, so I thought it was pretty good going. And also, didn't you guys think Hannah's stories were absolutely lovely? Yeah, I thought she did such a lovely job kind of weaving that story about the constellations, all of these different ancient cultures. We heard a bit about Greek astronomy and how they weave these stories in sort of the Japanese astronomical culture. And I really thought it gave a kind of lovely bit of context to the stars we were seeing. And I thought actually that ties in a way a little bit to what we're going to be thinking about this morning with space on screen. So we're going to be thinking about some of my absolute favorite Hollywood movies and how they presented some of the science, and some great examples of where they really got the science absolutely fantastically right, and a few examples where maybe they took a bit of a liberty. So if you haven't been to one of these before, I'm Ed Macaulay. So I'm usually based in London, where I'm a lecturer at Queen Mary University of London. Now, as we're going along, please do feel free to let me know if you have any questions, anything you'd like to ask. We'll have a bit of time, as usual, for questions at the end. If you're anything like me, I always think of the question I wish I'd ask like 3 days too late. So please do feel free, if you want to take a snapshot or anything, drop me an email, or if you see me around ship, please do come and let me know if you want to say hi or anything you found really interesting. I always love hearing questions from you guys, and all the interesting, fantastic stuff that you guys are interested in. Now, just looking out here, I've got to say, a couple of people, they're really super on brand here. So there's NASA t-shirt over there. I think that is absolutely fully on brand. So congratulations for coming with a NASA t-shirt, because we're going to be thinking about space on screen and science fiction movies. But of course, this is just a huge expanse of all different kinds of science fiction movies. So I was going to focus today on what I like to think of as like NASA movies. So these are all movies kind of broadly depicting NASA astronauts doing kind of reasonably realistic kind of things. So if you were coming for like Guardians of the Galaxy, I'm sorry to disappoint you. We're not going to be including that kind of stuff. So we're going to be considering kind of broadly kind of realistic things. We also have another exceedingly on-brand T-shirt here with all the different sci-fi spaceships. There's a few I can recognize. So we've got the TARDIS, Enterprise, Serenity. Some of these are still a mystery to us, actually, and I think even Google image search has failed us. But I'm sure, actually, if you assembled a room full of people who are all interested in space on screen, I'm sure we will be able to identify all of them. So maybe that's a bit of a challenge we can think about at the end. But it's great to see some people who are very much on brand there, okay? Now, as we saw at the end of last time, everybody loves a science fiction movie. So, we had this picture from the International Space Station back in 2017. All of the astronauts got together because they wanted to see the latest Star Wars movie. And I just love this idea that, you have genuine astronauts, they've got all this amazing stuff in space, but actually you can't beat sometimes going and watching a good Star Wars movie. And what I think is really interesting is that there's always been this interplay between science and science fiction. So I know for myself, when I was a kid, I was always watching science fiction, and that really inspired me about space, and that really was one of the factors why I thought, okay, maybe this is something, I want to go and study and kind of focus on for my career. And I think this is quite a common thing. Quite a lot of my colleagues, you watch these kind of amazing science fiction things, and it can be mind-blowing. And then, it can really help people to pursue careers in science. And then, of course, it works the other way as well, that there's kind of all kinds of incredible stories, so genuine stories of space exploration or using the context of space to inspire people, that really gives Hollywood a lot of ideas. But it's not just a kind of one-way thing. And where I think is really interesting is where you get this feedback, okay? So where you get real kind of science ideas, real science input coming from movies, and then also real science ending up on screen. I think that interplay is really interesting. So just a quick poll of you guys. How many of you guys would say, okay, I'm a real kind of fan of science fiction movies here? Okay, good fraction. Does anybody have a real favorite movie that they, what's your absolute favorite one there? 2001. Okay, absolute classic, 2001, A Space Odyssey. Is that anybody else's favorite? Okay, yeah, it really is an absolute classic movie, okay? We're not actually going to be focusing on 2001 this morning, but we've got a lot of kind of other kind of really interesting insights. But again, that is a great movie where they really went to great lengths to get the science kind of absolutely accurate. And I think, it really did inspire a lot of people to think about studying space. Any other favorite movies out there? Yes, what's your favorite movie? Arrival. Oh, that is such a great movie. Has anybody else seen Arrival? Isn't it absolutely fantastic movie, honestly? Really, absolutely great movie. So again, at least I'm glad you guys are mentioning these, because these are fantastic movies which we don't have time to cover this morning. But if you haven't seen Arrival, it's an absolutely great movie. I think you guys will absolutely love it. And there's some really fantastic science, some really interesting hypotheses on there. But I would actually like to start with one of my personal favorite movies, okay? It is a really good, fun science fiction action movie. The reason I would like to start with this is because this movie has a bit of a reputation for taking quite a few liberties with the actual science. And I think that's a bit unfair, because it actually puts quite a lot of authentic detail on screen, and I think there's some important stuff to take away with it, okay? So I would actually like to start. Can you have a guess? I don't want to.
I'm not, because when you said it took quite a few liberties, I thought it was a time travel related movie.
Oh, okay. We will be covering a bit of time travel. This one is not a time travel movie, but it is one of my favorite ones. It is, of course, Armageddon, Bruce Willis coming to save the world. How many of you guys have seen Armageddon? Okay, now I'll be honest, even if you think they take a few liberties, I've got to say this is an absolutely fully entertaining action movie. What do you reckon?
I said it's a Mick Jagger music video.
That's not a bad way of putting it. I mean, I love the tune from Aerosmith by that absolutely brilliant tune. So of course, just for the one or two people there who haven't seen the movie, essentially, Bruce Willis is an oil driller, and he's going up into space to save the world from a giant Texas-sized asteroid. I know we've got a few people from Texas. Who's from Texas here? Okay, not okay. So I guess Texas-sized is a bit of sort of Hollywood shorthand for just it's really big, okay? Because if anyone knows one thing about Texas, it's very big. Now, this has often been quite maligned as taking a few scientific liberties, okay? And of course, there are a few things which are not 100% accurate. But there is quite a lot that this movie actually gets quite accurate, and that they went to quite a lot of effort to portray the right kinds of things on screen. And I think that's quite important to focus on. So, even in this iconic shot here of them walking out to the space shuttles, they're all in the authentic, the pumpkin suit, the emergency orange suits for being rescued from the space shuttles. They've got the authentic Astro van over here. So, even just in this shot, it is a pretty kind of authentic thing of, what's going on in NASA. I mean, this is what it looks like in real life here, the real astrovan, the real astronauts. Of course, they don't tend to walk in slow motion quite like Bruce Willis did. They're not quite so serious about their NASA mission. But I think you can see here, it really does compare exceedingly well, right, in terms of the authentic details. And I think things like this, they do matter when you're putting these kinds of stories on screen to get these kind of authentic details. Now, they did take a few, shall we say, liberties with the astronaut training. It was clearly exceedingly compressed, but a lot of what they depicted was actually quite realistic. So, we saw last time that genuine astronauts, they really do train in these neutral buoyancy tanks. And in Armageddon, in the actual movie, they were training like this. So they were actually, collaborating with NASA on their training facilities there. So I think, we had Ben Affleck in the neutral buoyancy tank practicing there. So I thought, that was pretty authentic. We also, in the movie, they were flying on these T-38 training jets. And again, this is something that genuine astronauts actually do to get a sense of, the G-forces involved with liftoff. So I thought that was something else quite authentic. And then in the movie, their space shuttles, they go up and they dock with, I think they just call it the unnamed Russian space station. But again, quite an authentic detail, docking with Mir. So here, we've got a genuine space shuttle, and it did dock with Mir, the Russian space station. So in the movie, they docked because they needed to refuel so they could go and keep flying out to the asteroid. And in true Michael Bay fashion, essentially everything exploded after they left. So, we never got kind of, the whole thing exploding like this. But again, I thought that was actually a pretty accurate depiction of, shuttle launches and docking with space stations. And then another reason that I'm actually quite a fan of, the science and the conversation that Armageddon started is because it's actually inspired some genuine scientific research by some physics students here. So this was actually a research paper published by some physics students. Could Bruce Willis save the world? Now, you might say that the answer to this paper is, of course, Bruce Willis could save the world because he always does. But they actually looked into the science of this, and essentially what they found is that the nuclear weapon that he needs to blow the asteroid into, it would need to be about 1 billion times larger. Okay, so I think perhaps that's not too unreasonable. I think we can kind of give them that if they just need a large nuclear weapon. But I love it when you have science fiction action movies, and then inspiring people to think about genuinely how much energy would we actually need to split an asteroid like this. This actually wasn't the only paper inspired by Armageddon. And the other paper, I really like it because I think I mentioned I spent a couple of years living in Australia, where Armageddon is, of course, well known to be short for the Australian slang for Armageddon Outta here, which in a kind of Australian accent makes a bit more sense. And they managed to work that into the title of the paper. And in this paper, they calculated how big would the crater be if you had a Texas-sized asteroid impacting Earth. And essentially, they said the crater would be bigger than the entire planet. So clearly, it would be very bad news. Okay, so I'm just relieved that Bruce Willis went up there and sorted it out for everyone. But again, I thought it was great that just by having a movie, we've inspired some students to think about doing some genuine research. And then later, I think we're actually seeing some genuine kind of scientific and NASA work to think about, what would we do if we actually did need to save planet Earth from an asteroid. So just a few years ago, there was this fantastically successful NASA mission called DART. Did anybody read about this when it was going to chase down this asteroid? So it was a pretty cool mission. So they unfortunately, they didn't send Bruce Willis or any other astronauts, actually. Perhaps that's for the best, because it was very much a one-way mission. So the idea was to impact an asteroid and see if they could deflect it. So this is the genuine spacecraft here. This is a visualization of what was going on here. So here's the asteroid, and then the idea was to just try and crash this spacecraft into the asteroid and see how much they deflected it. And the mission was a fantastic success because they were able to impact the asteroid, and they were able to change the orbit of it. And if you can detect an asteroid early enough, you don't need to blow the whole thing up with a nuclear weapon. If you just very slightly nudge its orbit, then it's going to quite safely miss the Earth. So this mission really showed that if we thought we did need to deflect an asteroid from the Earth, we could actually launch a genuine space mission and we could go and deflect it. So in a sense, this is kind of like a real-life version of Armageddon. But of course, if you want to deflect an asteroid, you first have to know where it is. And finding asteroids is quite difficult because they tend not to be very luminous. Even relatively small asteroids can be quite dangerous. But just this year, a fantastic new observatory, the Vera Rubin Observatory, has just opened. And this is going to scan the entire sky every 3 or 4 nights. And one of the main things that it can do is detect asteroids in our solar system. And I think this is an absolutely beautiful photograph of the observatory and the night sky. And this is not photoshopped at all. This is just a long exposure photograph. And this beautiful Milky Way really is what you see up there. And this is an absolutely huge, very high resolution digital camera. And hopefully it's really going to be very, very good. It's already found thousands and thousands of asteroids. And I'm sure over the years of operation, it's going to find many thousands of more. So if there is a potentially dangerous asteroid out there, we think, hopefully we'll be able to find it. And, we now know if we need to, we've got the technology, we have some idea on how we could launch a mission to deflect it. So even though Armageddon, it's first and foremost a fun Hollywood popcorn action movie, there is a lot of really good, authentic scientific detail in there. And, we're now seeing some of the things that were, depicted on screen, some kind of, in a sense, how it's coming to life. So, I've always enjoyed Armageddon as, an entertaining movie, and I hope I've convinced you guys that maybe we shouldn't be quite so harsh on some of the science involved with it. Now, the next movie I would like to talk about is an absolute classic and really one of my all-time favorite movies. It is, of course, Apollo 13. How many of you guys have seen Apollo 13? It's an absolutely fantastic movie, right? So apparently when they were screen testing the movie with test audiences, one of the comments came back is they said, oh, this is just complete Hollywood nonsense. No one would ever be able to survive something like this. They didn't realize it was a genuine mission, okay? And it is an absolutely extraordinary story of survival of these astronauts. And it's an absolutely stunning visual movie. And of course, don't you guys think the soundtrack by James Horner, the score, absolutely beautiful. And in a way, it's become a bit of a kind of a kind of key piece of music for human space exploration. Now, this is a photograph of the genuine launch of the actual Apollo 13. And in the movie, the launch is just absolutely fantastically brilliant. They went to such great lengths to depict that accurately. And in general, they really went to amazing lengths all around to make this a very accurate and authentic movie. They did take a couple of very minor stretches, which I think hopefully we can forgive them. So let's see what they got right and where they took a few liberties. So again, this is another genuine picture of the Apollo 13 command module. And this was taken just after the capsule undocked, just before they were returning to Earth. And you can see here all of the damage there caused by the explosion. Now, of course, we all know what is the famous saying that you say when your spacecraft blows up and you need to get in touch with Houston. It's, Houston, we have a problem. Okay, so it's a real iconic quote. They took a few very minor liberties with this, okay? So it's actually, Houston, we've had a problem. So I think, if we're getting to this kind of level, this is kind of pretty nitpicking. Another great quote from the movie by the flight director, failure is not an option. So again, absolutely great quote, and one I love. Apparently also that was not actually authentically said. That was something we've got to thank the script writers. So that failure is not an option. So just remember, of course, failure is in fact always an option. It is always something that can happen. But again, I think pretty minor details at this level. Apparently, they did slightly amp up the drama of the astronauts in the capsule. They kind of stirred in a bit of dramatic tension there. I think that's not unreasonable. I think we can give them that a little bit of dramatic tension. But they got so many details correct. So do you guys remember in the movie they had the problem with the CO2 buildup, and they had to get the scrubbers there, and they made this thing out of like duct tape, and they got the oxygen scrubbers from the other spacecraft and brought it in. So all totally accurate, and this is a genuine photograph and exactly correct as in the movie. So even these kind of really small details like the oxygen scrubbers, they got absolutely spot on. Something that I was so impressed with in the movie, this is a frame from the actual movie. And again, I kind of have to just be clear, because the actual movie stuff just looks so similar to the authentic stuff. So this is a frame from the motion picture. And we've got one of the astronauts floating around in zero gravity. Do you guys remember this in the movie when the astronauts floating around in their spacecraft? Now, something which I'm perhaps most impressed with Apollo 13 is the lengths they went to get the zero gravity scenes correct. Does anybody know how they did this in the movie? Yeah, you're absolutely right. So, we saw last time, when we were thinking about how you can get a taste of being an astronaut. You can go on a parabolic flight. So the aircraft is basically falling towards the Earth as fast as you are. Now, NASA actually used this Boeing 707 for training their astronauts. So they put their astronauts to give them a taste of zero gravity. This thing would fly up high altitude and would fly in a parabola. And as it's flying on that and falling towards Earth, the astronauts feel like they're in zero gravity because they are, genuinely weightless. So it's something that NASA actually used to train their astronauts. And when they were thinking how to make the zero gravity scenes for Apollo 13, they thought, I know. So what they did is they put the whole set of the lunar module and the Apollo capsule inside this aircraft. And they went and filmed those zero gravity scenes while the aircraft was flying these parabolas. I mean, I just think it's absolutely extraordinary. So they actually sent the crew of the cast of the movie. So, you can see Tom Hanks as Kevin Bacon up there. They actually sent them for zero gravity training in this aircraft. So here they all are floating around in zero gravity in an aircraft in parabolic flight. And all of those scenes in the movie, when they're in zero gravity, that's not CGI, they're not hanging from wires, they're genuinely in zero gravity. I just think that's absolutely amazing, the lengths they went to get that correct. And actually, the cast of the movie, in the process of filming it, clocked up more zero gravity time than some of the original Mercury 7 astronauts. So I just think that's absolutely incredible in the process of making a movie to get more zero gravity time than an actual astronaut. So Apollo 13, absolutely fantastic movie. It is actually available on the ships, that you can watch movies on the ship system. It's an absolutely fantastic movie. So it works so well just as a piece of Hollywood, but also the detail that they went to get everything absolutely correct is just superlative. So you can probably tell I absolutely love this movie, and I'd highly recommend it if you want to give it a watch. Now, the next movie we're going to think about, just one last absolutely lovely detail at the end of the movie. So right at the end of the movie, the movie cast of Apollo 13, so we've got Tom Hanks over here, they're all picked up on the aircraft carrier, and they're all kind of meeting people. So this is Tom Hanks, who portrayed Jim Lovell. He shook hands with the genuine Jim Lovell on the aircraft carrier. And I thought that was an absolutely lovely scene to have the fictional Jim Lovell meeting the real Jim Lovell. He very, very sadly passed away just recently. But the last detail which I just loved about this is when they were going to do the handshake, Ron Howard said to Jim Lovell, okay, let's put you in an admiral's uniform, we can make you an admiral. When Jim Lovell retired from the US Navy, his rank was captain. So he said, no, I retired as a captain, I'm going to be a captain. So this is his actual genuine captain's uniform from the US Navy that he put on when he shook hands with Tom Hanks. So just all through the movie, there's just such a dedication to getting absolutely everything correct and being authentic. And I think it just comes through. So I just absolutely love this movie. It really is one of my absolute favorites. Okay, so the next movie we're going to discuss, do we have any fans of Gravity over here? Yeah. So this really was a bit of a landmark moment in kind of big space IMAX blockbusters here. Just come on, have a quick look. Who has seen Gravity already? Okay, so I won't have any spoilers here. Okay, we'll just focus on some of the details here. So this is a frame from towards the start of the movie here. So what we've got their space shuttle. They called it Explorer in the movie. I think that's reasonable. And essentially, to set the scene here, they're going up. We've got Sandra Bullock over here. She is fixing the Hubble Space Telescope. I love it with Gravity. I can never remember what the astronauts are actually called. So this is astronaut Sandra Bullock, and this is astronaut George Clooney over here. And his mission is testing the jetpack. Okay, so we've got Sandra Bullock. She is doing some upgrades to the Hubble Space Telescope. George Clooney, he is testing the space jetpack. And essentially, very shortly after this, there's a big space disaster and lots of space debris, and then the movie really kicks off. Now, they really went to extraordinary lengths to get all the little details corrected, so, all of the thermal protection system on the space shuttle and all the little nuts and bolts here. So there's a lot that they got right, and there's a few places where they did take some liberties. So let's dive into this and see what they got right, where they stretched things a bit. So George Clooney flying around in the manned maneuvering unit, pretty accurate, okay? So there's this now very iconic photo of Bruce McCandless doing the first tests of this. They actually found in the end the original idea of this suit was you could fly out and use it to retrieve satellites. In the end, they found the robotic arm kind of tends to work better. But in terms of the design of the suit in the movie, they got that pretty accurate. If I was grading the movie, I'd say you probably wouldn't have George Clooney doing flight tests on this suit at the same time as fixing the Hubble Space Telescope. But of course, then he wouldn't be able to go and rescue Sandra Bullock, okay, if he was just not there. So I think, they took a bit of artistic license, but I think, we can see why in the context of the movie. So Sandra Bullock is doing some upgrades to the Hubble Space Telescope, and also, pretty accurate. So the Hubble Space Telescope was designed to be serviceable and upgradable. So it was designed, it wasn't just going to be kind of launched and forgotten about. They thought we're going to be able to send servicing missions up to work on this. So I think there's an absolutely beautiful photograph of Stephen Smith and John Grunsfeld working on some upgrades to Hubble Space Telescope during the mission from Discovery. Now, back when I was a grad student, I was very fortunate because I got to meet John Grunsfeld, and his background is actually in astronomy. And he said, when he was growing up and thinking about what he was going to study and what he's going to do as a career, he just thought that, if you were in astronomy, the future would be that you'd be going up to space telescopes and doing services on them. So, of course, now, really, the Hubble Space Telescope is the only space telescope which, you can service now. It just tends to be easier these days to just launch a new one, basically, than sending something up there to service it. But that, that really was pretty authentic. There's one really interesting detail with Gravity where they kind of got things a little back to front. Does anybody remember what Sandra Bullock's character actually was in the movie? So her background was actually that she was a medical doctor. And the idea was that she'd invented something for medicine that they were going to be using that to upgrade the Hubble Space Telescope. And I think that kind of adds to her character because it makes her a bit more of that kind of fish out of water, rookie kind of astronaut. And there is quite a lot of interplay between, what goes on in like medical physics and what goes on in physics for astronomy. But in the case of astronomy, it actually kind of works the other way around. So I've got this photo here of some laser eye surgery. So there's the patient up there, and then there's a close-up of the patient's eye with what the laser's going on. Has anybody had laser eye surgery, actually? Okay, so if you had laser eye surgery, you've actually benefited from some developments in astronomy. And it was actually this idea called adaptive optics. So if you're doing astronomy and you're trying to look through the atmosphere is all turbulent and it kind of gets in the way. So astronomers developed this technique originally actually for spy satellites to counteract the effects of the atmosphere. It's almost a bit like noise-cancelling headphones, but for telescopes. And very similar techniques are actually used for adaptive optics for laser eye surgery. Because if you're shining a laser into someone's eyes, you need to very, very carefully track all the little motions and everything to get it accurate. And the technology based on that was actually kind of developed from adaptive optics. So I think there really is this interplay between medicine and astronomy. They just kind of switched that a little way around in the movie. I guess it makes the movie a bit more interesting because it helps to establish Sandra Bullock, she's not like a career astronaut. This is, her first space flight, and she's really, really being challenged by this. The other thing I'd like to point out, so in the movie, the space shuttle very, very badly damaged, and they can't return to it. So George Clooney, he goes and rescues Sandra Bullock, and they fly his little jetpack over to the International Space Station. Now, this is a genuine photograph of the International Space Station. And this is probably where they took the biggest single liberty with gravity. Because in the movie, they can quite easily go from the Hubble Space Telescope over to the International Space Station. And this is a bit of a stretch because they're actually in very, very different orbits, so very, very different altitudes, going very, very different directions. There's no way you could fly over there in a little jetpack. You'd need actually quite a big rocket to change your orbit like that. And I think it kind of reinforces this idea that like space is just like one thing up there, and you throw stuff into space and it all just kind of floats around. Orbits don't work quite like that. But of course, it wouldn't be much of a movie if they're just kind of stuck in the shuttle and nowhere to go. So I guess we've got to allow them in the movie a bit of artistic license to get from place to place. Now, this is a genuine photograph of the actual International Space Station with an actual shuttle docked to it. But I think, in Gravity, they went to such amazing lengths to get all of the details correct. And of course, they won the Academy Award for Best Visual Effects for the movie, and I think absolutely quite rightly, because it's an absolutely stunning, real IMAX experience. And I was very fortunate because I actually got to meet some of the guys from Framestore, including Chris Lawrence, who won the award. And this is the company that was involved with the visual effects for the movie. And something that they said, which I thought was quite interesting, is one of the most difficult things to get right in the movie was the solar panels in their CGI model. Because solar panels, they're designed to absorb light and they kind of reflect light in a kind of very particular way. And it took a lot of work to get that right in the movie. But I think we all agree, when you watch it, it really does look absolutely right. Now, what I think is quite interesting is the same company that works on Gravity, they also worked on the next movie we're going to be thinking about, so The Martian. And it's the same company. So this is a frame from the movie The Martian. And I think, doesn't it just look so amazingly realistic? I mean, it looks like a real thing. This is the spacecraft from The Martian. How many of you guys have seen The Martian? It's a great movie, isn't it? Absolutely super. How many of you guys have read the book? It's a great book as well. If you like the movie, I'd really recommend the book. So it was the same company that worked on the visual effects for both movies. And if you take a look at the solar panels on the Hermes spacecraft in The Martian, do these look a little bit familiar to you guys now? So they spent so long working on the solar panels for Gravity, they just copied and pasted them over for the solar panels in The Martian, which I think makes sense just from a movie production point of view. But something I like about this as an authentic detail is that if you were actually making a Martian spacecraft, you probably would just use the same solar panels. So it's a nice example of where Hollywood was kind of taking a bit of a shortcut, but actually, could be quite authentic. Now, The Martian, again, another absolutely wonderful, wonderful movie where they get so many things right. So I'd like to, let's have a look at some things they got right. There's just a couple of places where they took a few liberties here. So in the movie, the astronaut Mark Watney, so he's trapped on Mars because there's this big storm so they have to take off, and then he's left behind. Okay. Now, this is actually where they took a bit of a stretch, and they did take this in the book as well, because the atmosphere on Mars, and this is a satellite photo of genuine planet Mars, is very, very thin. So you wouldn't really ever get a storm that's going to be strong enough to blow over a spacecraft, and you would need to leave in a big old emergency. But again, I think from a movie point of view, you need something to kind of kick the action off. So I think this is, we can allow them a little bit of artistic license with this. So in the movie, so Matt Damon, he survives by growing potatoes, okay? And again, this is something quite authentic. So this is in the International Space Station. They do actually grow their own vegetables there. And this really is something that we're thinking about is going to be necessary if you're going to explore Mars, because you can't take all your food with you. If you can grow some stuff there, that's going to make life a lot easier. So it is something that NASA is actually thinking about for genuine Mars missions, growing things on the surface of Mars. Now, this is a frame from the movie, and again, I kind of have to be clear because the production design is just so authentic here. So another really interesting place where they took a bit of a liberty with the movie, which I think was actually the right call, is, did any of you guys notice this? So whenever they're on Mars, in the actual planet, Martian gravity, it's slightly more than a third that of Earth's. But in the movie, Ridley Scott said, okay, let's just forget about that, basically. So in the movie, on Mars, they never really try and do too much with making the Martian gravity look less than Earth's gravity. And I've got to say, I think that was actually the right call, because when you're watching the movie, you just don't think about it, right? It all just looks like Mars. You never think, wow, does that gravity look a bit too strong? It just looks absolutely fine. And I think they could have spent millions and millions of dollars CGIing everything to look in kind of slow, lower gravity. And I don't think it would have made the movie better, and I think it might have made the whole thing look a bit more kind of, a bit more fake. So I think this was one example where they didn't strictly follow the science, but actually I kind of agree with it. I think it's probably the right call. It just makes the movie more grounded, basically. So this is a photo of our genuine Mars explorer. And the thing I'd like you guys to take away from this, so this is the Perseverance movie, Perseverance rover, is just how good it looks compared to the actual movie. They went to such great lengths to really get that authentic. This is our genuine Mars explorer, but maybe in a few years we might have actual humans on the surface of Mars like we saw in The Martian. Now, the last little detail I'd like to share with you guys from The Martian is actually one of my favorites. So at the end of the movie, they launch another crew back to explore Mars, and it's a really nice ending. Now, that footage of the launch was actually genuine footage of the Delta IV Orion test flight, where NASA was actually testing their genuine Orion capsule, which is designed to take humans back to the moon. So again, already quite authentic. But inside the capsule was actually a page from the script of The Martian, which I thought is just absolutely lovely. So right up there in the capsule, there's something from The Martian, and then that features back in the actual movie. So I thought that was a lovely kind of detail to really add a bit of authenticity to the movie. Now, The Martian, absolutely great movie, but it's not actually the only movie where Matt Damon is an astronaut stranded on a planet, and in the end, Jessica Chastain comes to the rescue. There is actually another fantastic science fiction movie along those lines. Okay, of course, they take things in very different directions. Okay, and it is, of course, Interstellar, another absolutely superb science fiction movie. How many of you guys have seen Interstellar? Okay, again, absolutely great movie. If you can, really, if you can see it on a big screen, it's just such a sort of stunning visual movie. So this is one of their spacecraft they used to kind of go down to planets, the Ranger 1 spacecraft. And just the production design, it's just fantastic here. I mean, the thermal tiles here and the thermal blankets, all this stuff, and the reaction control systems, it's just so authentic. They've clearly spent a lot of time studying, genuine space shuttles and gone to a lot of work to get things right. Now, in the movie, they all go down to this planet here, and there's some really interesting effects involving time dilation. Do you guys remember this in the movie? So for every 1 hour they spend on this planet, it's 7 years for the other astronaut left in orbit. Now, this is kind of, you might think, wow, that's kind of crazy, but this really is actually very, very accurate. So what Einstein's theory of relativity tells us is that time does run at different rates depending on how close you are to massive bodies here. So this idea that maybe time is going to be running at a different rate if you're on the surface of a planet, so you've got 1 hour passing and then it's going to be 7 years if you're up in orbit, is actually really grounded in real physics. Now they did kind of push it so they max it out, how much you could get this time dilation effect. But it's not just something which is kind of a bit esoteric. It's something which actually really matters for all of us. So this is a graphic of a GPS satellite. So the kind of satellite we all use for navigation. And GPS satellites, they work on very precise timing. So on a GPS satellite, they have an atomic clock, and it's essentially beaming out a time signal, and then you can use that from multiple satellites to triangulate your position. But just like in Interstellar, time is actually running at different rates in these GPS satellites. So because they are up in orbit, the time is going to be running at a different rate. And if you didn't correct for that in the GPS satellites, your position would be off by miles and miles and miles. So you might think, okay, well, time dilation, that's a lot of fun in a science fiction movie in Interstellar, but really doesn't matter too much for everyday life. But it's actually really important to get right if you are using GPS. And it was great to see it portrayed on screen like that in Interstellar. But that was just one of the things that they got right, and they really went to such great lengths with Interstellar, because they actually made the movie in collaboration with Kip Thorne. How many of you guys heard of Kip Thorne? Okay, so he is one of the leading experts on the theory of relativity. He's based in Caltech, and he recently won the Nobel Prize in Physics for some of his work on gravitational physics. And he was a consultant in the movie, and he really collaborated on getting a lot of those movie details really accurate here. So this is a frame from the movie of this black hole gargantua, a supermassive black hole that they go and visit in the movie. Now, this frame was made with computer simulations. But the thing I'd like you guys to take away is that this is not like just a CGI thing of a black hole. They actually collaborated with Kip Thorne, and they actually solved the equations that Albert Einstein wrote down to describe how space and time will get bent around a black hole. And they actually used that to work out what light is going to look like as it's getting warped around the black hole. So you can see here we've got this big disk going around the black hole called the accretion disk. So this is very, very hot plasma that's being pulled into the black hole. And what you can see at the top and bottom of the black hole are actually images of this disk from the other side of the black hole, and they're being stretched around the black hole by what's called the gravitational lensing. So it's stretching the light around, and that's something that you can see. And it's not just like something that they kind of did a quick CGI thing to kind of make it look right. They really spent a lot of time solving the actual equations that Albert Einstein wrote down to get the black hole looking just right. And until quite recently, our best view of what a black hole actually looks like was this simulation. And the work that they did to get this simulation correct is now actually used in astrophysics to work out what gravitational lensing of other things looks like. So this is just an example of some of the the background work that went into getting this black hole correct here. So this is where the black hole is. They've taken away the accretion disk. And these lines give us some idea of how the gravity of the black hole is bending the light around it and giving us that amazing gravitational lensing effect. Now, a few years ago, so this is back in 2019, has anybody seen this actual image of a black hole? So this was a real big breakthrough in astrophysics. So using an array of very, very big radio telescopes, these astronomers were able to make a genuine image of actual black holes. Okay, so this was the first time that we've got an actual image of a black hole. So the black hole is in there. These lines here actually tell us a bit about the polarization, and then this swirling thing here is the accretion disk, so all of that plasma flowing in. And it's amazing how close they kind of got things right with Interstellar, because no one had ever actually seen a black hole. That's all based on simulations. Now, clearly there are some differences here, but in terms of the big features of the accretion disk and seeing the accretion disk getting lensed all around the black hole, they actually got that absolutely right in Interstellar. Now, they did take a little bit of artistic license with the black hole in Interstellar. They actually made the black hole spin basically as fast as they could, because Christopher Nolan said, that would kind of really look right on screen. And they did a few kind of tweaks with the disk, really for audience expectations, because I think in our minds we all have some idea of what a black hole would look like, and if it was going to look too crazy with too much gravitational lensing, that might look a bit weird on the movie. Now, one of the last things that I'd like to share with you guys is another thing from Interstellar, which they really went to great lengths to get right, and really did go against a bit of what audiences might expect this would look like, because they fly through a wormhole. Do you guys remember this in the movie when they fly through the wormhole? And I think, we've all seen like Deep Space Nine, right? We all know what a wormhole looks like. It's the thing, and you fall into it. So for Interstellar, again, they worked with Kip Thorne, and they actually calculated what a wormhole would actually look like. And it doesn't kind of look like a sinkhole. It almost looks like a kind of spherical thing where you're getting this very weird lensed view of what's on the other side of the wormhole. So again, this is not just CGI. This is a real result of studying relativity and working out what a wormhole should look like. So this is what it looked like in the movie, but this is some of the background that went into it. So they actually did a technique called ray tracing, so following bundles of light as it's passing through this wormhole and using it to work out what the light is going to look like when it comes out the other side. So they really went to such fantastic lengths, and they've published their results in a couple of genuine scientific papers, which really are kind of very informative for doing this kind of work for real physics. So I've got to say, with Interstellar, we really got to take our hats off to them, because not only, it's an absolutely visually stunning movie, but they went to such lengths with getting that physics and relativity correct that, we're actually really learning things and applying it for astrophysics. So again, another absolutely brilliant movie there. Now, as you can probably tell, I've always been fascinated by this kind of thing, and curved space-time and time dilation and length contraction, all these kind of amazing things from relativity. And when I was a kid, I loved watching about this kind of stuff in movies, and it's one of the reasons I went to university and studied physics, because I wanted to learn some more about it. But recently, over the past couple of years, I thought it'd be great if these kind of things could be made a bit more accessible. So I've actually just recently published my very first book about this. So it's called First Steps in Space-Time. So if you are interested in things like time dilation and some of these things that we have seen in Interstellar, I hope you really might be interested in this, in going into a bit more depth about what's going on in these kind of things. Because the thing I found, when I was like a high school student, is there were some great books which I really enjoyed reading, the kind of popular science books, which described this stuff, but they didn't really go into detail in terms of what was happening. But I couldn't manage to read a university textbook by myself. So I like to think of this book as kind of somewhere in between, like a university textbook and like a kind of popular science book. So maybe if you've already read a popular science book and kind of enjoyed it, like to go into a bit more detail, and you're not going to be afraid to see a little bit of the actual equations, how things actually work, I really hope you might enjoy this. And it is actually for sale in the shop on deck 6. Okay, so if you'd like a bit of holiday reading, take a look down to deck 6. You'll be able to find some copies there in the ship shop. Hope you enjoy it, and of course, very happy to answer any questions that you guys might have about it. Okay. And just a little heads up for next time. Okay, so we've already touched on a few ideas from astrophysics about black holes and wormholes and gravitational lensing. Next time, we're going to be exploring some more details from cosmology in a bit more detail. We're going to be thinking about why cosmologists think most of the universe is invisible and what this stuff potentially could be. So we're going to be focusing on the invisible universe, okay? So we're kind of going to be shortly wrapping things up for the time being. I've loved hearing a bit about the movies that you guys are interested in. I think what we'll do, because we're kind of coming up for the hour, maybe we'll take a few questions down there after we can kind of let people go if they have other things that they need to be heading off there. But I really hope you guys have enjoyed hearing about some of the science in movies, maybe some of your favorite movies, seeing some of the things where there have been a few stretches, but also some of the things where not only did they really get the science correct, but it's actually gone and inspired some kind of genuine other scientific papers. So I hope maybe there's been a few surprises, and I really hope you've enjoyed it. But I just want to say thank you guys all so much for coming and all the questions and sharing things you've enjoyed about the movie. And I hope you guys have an absolutely fantastic time on the rest of your time here. But I just want to say thank you guys so much for listening, so thank you.